Okay, in this video we're going to talk about, in geometry, what's called similarity and how it relates to ratios and proportions. Okay? Remember, this is about geometry, and you'll see up here that this is not for my students necessarily, but this is for other teachers who might want to use this video. This is for the Common Core State Standards, and especially in California, with high school geometry and similarity and right triangles, standard A1 and then standard A2. Okay? So what we're going to answer in this video are the following questions. What is similarity? What is a dilation? Which shapes are similar and which shapes are not similar? Okay? So let's get started with the very first question. What is similarity? Now, similarity in geometry means that you have two shapes. Let's just take, in polygons, let's just take a square, for example. And let's just make it a little bit bigger. So two shapes are similar if they have the same shape, or if one is like a mirror image of the other. Now, it doesn't say anything about how large it is, right? But the proportions, and that's where ratios and proportions comes in, the proportions remain the same. Okay, so for example, let's say that each one of these sides was 1. So the ratio from side to side would be like 1 to 1, right? Let's say, but in another square, again, we know that all sides are equal, and let's just say this was 2, 2, 2, and 2. Again, the ratio from side to side would be 2 to 2. So what do you notice about these two ratios or proportions? Well, they're equal, aren't they? Okay, so similar objects retain the same ratio or proportion even though the size might change. Okay, now when a size changes, that's what's called a dilation. All right, so it might move from like this small square, for example, into a larger square. Now, the way that happens is something called a transformation, and I'm not going to talk about that yet. We're not going to make this too complicated. I just wanted to give you an idea of what similar means, right? The proportions of a shape remain the same even though the size may change, okay? Now, what are some of the other shapes that are similar? Well, a circle, for example, and then a larger circle. Those are both similar because, again, the proportions remain the same, okay? What would be another example of a similar, for a similar polygon, for example? Okay, equilateral triangles, another example. Remember, equilateral triangles have all the same sides of equal length, which means that the angles are of equal lengths. So squares, circles, and equilateral triangles are all what they call similar polygons, okay? So squares, circles, and equilateral triangles. And again, what makes them similar? The proportions or the ratios remain the same. Now, which shapes are not similar? Well, rectangles, for example, aren't necessarily similar. Let me give you an example. Now, remember the definition. The proportions of the sides, or for example, of a critical characteristic have to remain the same. But if I take two rectangles, let's just say, for example, this side is 2 and this side is 1. But this side might be 4 versus this side, which might be 1. Okay, or let's say it's just 1.5 to make it a little different from that one. What's the ratio here? The ratio from side to side is 2 to 1. What's the ratio here? The ratio would be long side to short side would be 1 to 1.5. And if you were to actually simplify these, right? Actually, let me just change that so I can make it a little bit different. you were to reduce this, you would see that this ratio is 3 and this ratio is 2. Now, I said that because rectangles aren't necessarily similar, right? They can change depending on whether the proportions change. That's not true for a square. Squares will always have equal sides to one another, so the ratios will always be 1. What's another shape that won't necessarily be similar? An oval. Let me give you another example. Okay? Or an ellipse. That's just another way of doing it. What we can do with these guys is we can take the ratio of the two cross diameters, right? And let's just say this ratio is something like, I don't know, let's say that's 2, and let's say this direction it's 1. But in this oval, all right, let's say something like 4, and let's say that this side is 3. Again, it doesn't look quite proportional, but again, you can just take the ratio. This would be like 1 to 2, and this one would be 3 to 4. Reducing those to, like, let's just say decimals, and you could compare it. That would be like a 0.5, and that would be like a 0.75. So again, you see that these are not similar because even though these are both ovals or ellipses, right, the proportions can be different. So let me just go ahead and write these down. Okay, so I hope that was helpful. We answered the question, what does similarity mean? And similarity just means that the shapes remain the same proportions, even though they might be larger or smaller. And making something larger and smaller is what they call a dilation. You usually just like multiply it by some kind of what's called a scale factor, all right? Like this one, for example, just multiplied it by 2. I still got the same proportions. Circles are also proportional, which means that they're similar. And again, the way to do that is just like, for example, take the two diameters, and you'll notice that the lengths of these two diameters would still be the exact same thing. This might be like a 1 to 1. This might be like 2 to 2. They still come out to be 1, for example. Same thing with equilateral triangles. The distance between here and here might be like 1 to 1 to 1. This might be, for example, 2 to 2 to 2, but reducing those would still be exactly the same, all right? And that's not necessarily true for rectangles, ellipses, and isosceles triangles. Okay? Notice again that these two guys are equal, but it's not necessarily those. So let's just say that length is 2 to 1, and let's say this length is like 3 to 2. 2 to 1 equals 2. 3 to 2 is equal to 1.5. So the proportions are